exponents, okay? Our first rule we're going to look at here is multiplying with exponents. So we see here this is x to the a times x to the b. And when we do that, when we multiply, we're actually going to add the exponents, a plus b. So when we look at that with numbers here, I have x to the second power times x to the fifth power. I'm going to add 2 plus 5 to get 7. Now, why do we do that? Okay, we do that because if you write it out, okay, x squared is going to be x times x. Okay, that's your x squared. And then I'm going to multiply that times 5 x's. 1, 2, 3, 4, 5. Now that can be pretty annoying depending on how big your exponents are, which is why we have this law. But if you see, we can add 2, 3, 4, 5, 6, 7. There is your x to the 7th power. Okay, so instead of having to write all that out, you can simply add your exponents. 2 plus 5 is 7. Division will work the same way, except when you have the same base, these are both x's, you can subtract your a minus your b. So it's going to be x to the a minus b. So if we do that with numbers, x to the fifth divided by x squared, I'm going to do x to the 5 minus 2, which is 3. So if we kind of write that out, 5x is on the top. 1, 2, 3, 4, 5. I'm going to divide that by 2 x's in the bottom. Okay, and I'm going to go ahead and start canceling. We can cancel when they match. So x over x cancels, x over x cancels, and look at that. We're left with 3 x's. That's my x to the third. So again, you can write all that out, but that can be pretty cumbersome depending on how big your variable is. So that's why we have this law here to do it a little bit quicker. Let's take a look at some examples. All right, on my next slide, it says simplify to a single power of 4. I have 4 to the 6th power divided by 4 to the 4th power. So remember with division, I'm going to subtract. So I'm going to take 6 and subtract 4. So I'm going to do 4 as my base to the 6 minus 4. Well, I know that 6 minus 4 is 2. So this answer is going to be 4 to the 2nd power. It just says to simplify to the single power of 4. So that would be your answer for now. You can simplify that. 4 squared is 16, but we can leave it like that for now. My next one says simplify to a single power of 3. So I have 3 times 3 to the 4th. If you don't see an exponent, there is a 1 there, okay? So we're multiplying, so I'm going to make 1 base, and I'm going to add 1 plus 4. So 3 to the 5th power, okay? Again, there is a numerical value for that. 3 to the 5th power is a number, but we're just going to leave it like that for now because the directions tell us to leave it, okay? I have 1 3, and then I'm multiplying it by 4 more, so I have 5 total 3s there. All right, let's look at another example here with multiplication. So I know it's multiplication because I see these parentheses, okay? So that's multiplication. So I'm not changing any math that you've already learned. So we're going to multiply our coefficients. 2 times -5 is equal to -10. And then I can look at my x's. I have x to the 5th. Now you can only multiply ones with the same basis, so I can only do the x's. If there were y's, they would have to be separate. 5 and 4, I'm going to add them. 5 plus 4 is 9. So your answer is going to be -10 x to the 9th power. Okay, we just put them right next to each other. That's what you get when you multiply 2x to the 5th times -5x to the 4th, -10x to the 9th. Last example here, same thing. I'm going to multiply my coefficients. I have 3 and 9. 3 times 9 is going to be 27. And then I'm going to look at my q's. Q to the 2nd power times q to the 3rd power. I'm going to add them together. 2 plus 3 will give me q to the 5th power. So my answer there is going to be 27 q to the 5th power. Okay. All right, that's it for our video. Go ahead and practice in your Delta Math.